Bueno, vamos a ver. Ya estamos viendo. ¿Sí? Ok. Muy buenos días a todos, bienvenidos. Este es un taller que hemos venido preparando en conjunto con la empresa Signermet, con Movela, Tengo entendido que tenemos muchos conectados hoy de forma virtual, más de 80 personas. Me hubiera encantado que hubieran podido estar de forma presencial, pero haremos todo lo posible para transmitir lo que hoy realizaremos en este taller. Voy a presentarles al director de la Maestría en Ergonomía y Diseño Universal, también director del programa de Diseño Industrial, Juan Sebastián Ávila, quien va a presentar el evento. Juan, bienvenido.
Gracias, Beatriz. Bueno, para nosotros es un placer tener de invitados hoy la empresa Exens. Vamos a hacer una demostración en el marco de la Maestría en Ergonomía y Diseño Universal y el programa de Diseño Industrial. Para nosotros también es importante hacer estos eventos para conectar la industria con las tendencias, con las nuevas tecnologías emergentes que están cada día inundando el mercado y que ustedes van a ser testigos de cómo esto va a cambiar de la mano con la ampliación de las redes como la 5G, el 4G, pues el futuro del diagnóstico, el futuro de los diagnósticos laborales. Para los que están conectados de forma virtual, pues muchas gracias por conectarse, y los presentes también darles las gracias. Y una especial gracias a nuestros invitados, a Jordi, a André, a Natalia, que ahorita pues va a hacer la presentación un poco más en detalle de ellos de Noviembre y Cinermet, porque para nosotros como universidad es importante siempre tener las puertas abiertas a todas estas novedades, ir formando públicos, ir empapando a las nuevas generaciones en cómo estas tecnologías van a cambiar el futuro de estos escenarios como tal. ¿Listo? Thank you very much for coming here and share with us your knowledge. Here is a big space, a big opportunity to connect, to share information. So thank you very much again.
Hola, buenos días a todos. Para aquellos que no me conocen, mi nombre es Natalia Rodríguez, yo soy especialista de producto de la empresa Cinermet. Nosotros somos los aliados de Movela para Colombia en Latinoamérica. Y bueno, esta es una gran oportunidad. Muchísimas gracias a la Universidad del Bosque por este espacio, porque de alguna otra manera, como muy bien lo decía Juan, es una oportunidad de conectarnos, de poder establecer nuevas relaciones, proyectos a futuro, sobre todo en este campo de la ergonomía de los factores humanos, que es un campo totalmente nuevo para muchos. Y bueno, qué mejor que poder utilizar la tecnología y poderles presentarles a ustedes cómo se puede implementar esta tecnología en los proyectos de innovación. Entonces, el día de hoy el taller va a estar enfocado específicamente en poder presentarles cuáles son las nuevas metodologías que se utilizan, cómo se puede implementar la tecnología en este campo, basado en la metodología que ustedes ya conocen, temas que son importantes en cuanto al retorno a la inversión, que es un tema que seguramente muchos se preguntarán, y sobre todo casos de éxito. Entonces esta es una gran ventaja que podemos tener. Quisiera dar un agradecimiento muy fuerte del esfuerzo que hicieron André y Jordi para poder estar con nosotros en Movela. André es nuestro líder de cuentas a nivel de Latinoamérica y Jordi es nuestro líder de desarrollo de proyectos a nivel internacional. Son los expertos de Movela y van a estar con nosotros el día de hoy. Importante para que de pronto todos lo sepan, vamos a hacer una charla Spanglish. Para aquellos que de pronto necesiten traducción, en el chat de la transmisión les van a enviar un link para que puedan escanear el link y poder tener subtítulos durante la presentación. Si requieren de manera adicional alguna traducción, bueno, tenemos a André, Santiago nos va a apoyar y yo los apoyaré en cualquier momento. Muchísimas gracias por haber venido y bueno, espero que lo disfruten. Muchas gracias.
Muchas gracias a ti, Natalia, a todos que organizaron este evento. Voy a intentar en español en el comienzo y después voy a pasar la palabra para Jordi, que va a hacer la presentación en inglés. Pero como Natalia dije, si necesitan algo, estamos aquí para intentar ayudarlos. Como dije también, soy el ejecutivo de cuentas para América Latina, entonces estoy a frente de las ventas en la región. Y tenemos Jordi aquí, que es un experto en nuestras soluciones y está muy enfocado en los trabajos con la ergonomía y vamos a discutir la tecnología, pero también casos de uso y para de ahí que tengan ideas de cómo podemos utilizar los equipos en la industria, que es el más importante. Entonces, paso la palabra para Jordi. I'll give you the mic from now on, and please take care of these guys. Y si tienen alguna pregunta a cualquier momento, intentemos hacer algo muy natural, como levanten la mano y nos pregunten directamente para que no se queden dudas. Y así vamos. Muchas gracias por todos.
Gracias, André. Buenos días a todos. Mi nombre es Jordi. That's my Spanish. So, thank you very much all for attending today. Like I said, my name is Jordi. I am working for almost 4 years at the company Movella. From background, I'm a physiotherapist and a human movement scientist. So I've been working as a physio for almost 10 years, treating people, injuries, mostly in sports. But I have my master's degree in the human movement sciences from the University of Amsterdam. So I'm from the Netherlands. And today, the goal is to, like the title says as well, we want to talk about what can be the future on how to make workplace economics and workplace analysis more safe. If it's up to me, it's a very open discussion, so feel free to raise your hand, interrupt me, ask questions. We can have open discussions. It's not like you sit there and I talk, that's it. So I need you guys today as well, and thank you for joining. So I will grab my pointer. What are we going to talk about today? I will do a very brief introduction to Xsense. Xsense is the product Movella sells. Then we will talk about multiple ways how to perform workplace analysis in general. I'll tell you something about the motion capture system of Xsense, how we do ergonomics analysis with Xsense, and then I want to talk about our customers, how do they use it, some customer cases, and then we already go into some nice conversations and why the workplace ergonomics analysis with Xsense has a good return of your investment. So why is it actually good to buy this? About our company, Xsense is a company from the Netherlands. It started actually as a spin-off of the University of Twente in Enschede in the year 2000. And over the last 25 years, so next year we will celebrate our 25th anniversary, we have been developing motion capture technology. So we have a global presence. We work with a lot of different companies, like Cinemet is one of our representatives here in Colombia. And we work in very different areas. So some of the things we do: entertainment, health and sports, and industrial. So you might know some of these brands: Netflix, EA Sports, Facebook, Apple. These companies, they use our technology to make movies, films, games, anything. So that's a complete different branch, but they use the same technology. Then we have industrial, NASA, Boeing, NVIDIA. They use also our sensors, but they use one sensor for super accurate orientation technology. So the sensors are being used in self-driving cars, drones, UAV vehicles, that kind of stuff. My apologies, I have some asthma issues, so no COVID. I did a test, it's fine, but sometimes I have a little cough. So what we focus on today mainly is health and sports. So these are a few of our companies we work together with. But to give you a more brief overview, this is some of the people that use the Xsense technology in many different applications. So we have universities, we have research institutes, we have commercial companies. They all use motion capture technology in a very wide sense. So I hope to give you a little bit of an idea where people use it. And now we're going to deep dive a little bit more into ergonomics, because that's what we're here for today. So, in general, how do we perform ergonomics analysis? Is there somebody in the audience that does already do multiple analysis a day, a week? Yeah? How do you do it? Mm-hmm. Mm-hmm. Yeah. Yeah. Okay. Okay. Thank you. Yeah, I think I understood it. Thank you. Ah, nice. Yeah. Yeah, for the arms, yeah. Mm-hmm.
They capture for 2 minutes
Oh, yeah.
recollect the data and just use the more important data and persist to get
Yeah.
information to analyze the process in text.
Ah, okay, yeah. So that's a really nice use case of how you can use part of the Xsense technology, develop something yourself, and then make use of that data. So it already shows with all the other business lines that the technology is super broad, and that also makes it sometimes difficult because how are you going to use the technology? That's why I want to talk about a little bit more today. So if you look in general in how can we do an assessment in ergonomics, we have the pen and paper methods. So you have a screening, you have a ruler, a reba, a NIOSH form. You go to the workplace, you make a video, you assess it by hand, and you make sure that you fill in all the data, right? Everybody knows that. Then you have something new coming up, the AI video technology. You point your phone at somebody, a very nice stick figure appears in the screen, and then you record that data, and it spits out a nice analysis. For example, a ruler or a reba, something else. Then we have process line software. For example, Siemens Process Simulate, Siemens Technomatics, Dassault 3D Experience, Navo Live, all types of software that are designed to basically create a process line, but a partial module in the software is also to do ergonomics analysis. So that's an option. And of course, you have Xsense, we are an option as well. So basically we have 4 different ways on how to do ergonomics analysis. So if you then look at motion capture, what are the main benefits of using motion capture compared to the other 3? If you do an analysis by pen and paper, so let's say I do an analysis and you do an analysis and Andre does one and you do one, probably if we look all at the same video or at the same person, if we do it perfectly well, we should have 4 the same outcomes. However, we see a lot that when multiple people score the same person, that they do not always come up with the same outcomes. So how objective is an analysis when we do it with the pen and the paper method? If we use technology, either video AI, the process line software, or motion capture, it is the software, the computer, the sensors that score the person. So there is no discussion anymore because I saw this, you saw that. The software scores and it's always the same. So when you have outcomes from technology, you have 100% objectivity, and immediately you eliminate the observer bias. Which means when I go to a workstation and I already know this is a red one, I will be focusing on seeing difficult movements. So before even going there, I already set up in my mind a little bit different. We call that observer bias. If you score with the system, there is no bias anymore. The nice thing with motion capture, video AI, You can use it anywhere. You can go into a manufacturing place, you can go into a forest, you can go on top of a mountain. It doesn't matter where you go, you can always have the data. However, if you look at video, if I make a video of somebody that goes inside of a car, I cannot see him anymore. However, he is still moving in the car, placing a dashboard, placing a center console in a car, so we need that data. That's where motion capture comes in. Just put the sensors on. The sensors always gather all the data. So there's no occlusions or people moving in front of each other. You always have the data in any environment. Last, very important, to give you an example, I was at BMW in Germany, and they wanted to analyze a workplace where somebody was assembling the dashboard. What did they do? The person stands at his workplace, he gets all the parts, puts together his dashboard, and they make a recording of that with the video camera. They let him do that process 3 times, so the dashboard comes by, then he goes to the next dashboard, and then he goes to the next dashboard. In total, to score that by hand, it took them 1 day to have the analysis finished. However, with motion capture, the data is in the computer, you press the button, and you have the outcome. So instead of 1 day being busy with recording, analyzing, scoring, it's 10, 15 minutes, and instead of investing a lot of time in getting to results, you have immediately the results, so you can spend all the other time you have on actual improving the situation. And that's basically what I always like as being a physiotherapist, a scientist. I want to help people improve instead of focusing a lot of time on getting to a result. So that's where this is very important in using this. All clear so far? Not speaking too fast? Okay, good. So what we try to do with Xsense is we try to get from a pen and paper assessment using motion capture into meaningful parameters for ergonomics. If we look at the general pen and paper methods, you have Rula-Riba, you have NIOSH, you have EAWS. All these different kinds of assessment methods, they all focus on a specific thing. Rula, rapid upper limb assessment. So I only know something about my upper limbs. NIOSH, mainly for handling loads and lifting. EAWS is basically a lot of this together in one scoring system. However, what I want to show you with this is that there's not one big assessment tool that looks at everything. You always have to select, okay, I want to now focus on the upper limb, I do a ruler. Oh, I want to now focus on lifting, I'm going to assess with a NIOSH. Okay, now I want to look at a broader perspective, I calculate my AEWS. So maybe for one workstation, you have to do multiple different assessments to get a complete picture. That's where people came with the AI tools. Like I said, I really like these kind of tools because what they can help you, in my opinion, and I don't know what your opinion is about it, but I think it is very good to have an initial assessment. Like, you want to go to a workplace and quickly look at, okay, what's happening here? I point my camera at my colleague or the person you want to measure. It's very quick. I have the multiple scoring methods already in there, and it's objective. So we already win a lot compared to doing a manual assessment. However, the main disadvantages of these tools is the data quality, because if you see this stick figure, now the lines are okay-ish, but he's wearing clothes, protective wear. So the quality of that data is mwah. The funny thing actually is if you have a lot of these AI tools, how do you think they create the AI? The data input is from Xsense, most of the times. So they buy an Xsense suit, they train their models, and then they build the tool and the app. So the basis is actually input from Xsense, but the video is just not good enough to translate that data into good outcomes. But it gives you good analysis to just, it's better than only looking with the eye. So what I always say, if you want to use these type of tools, feel free to do it for, I say, a quick and dirty analysis. It's quick, you will get some insights, but if it tells you it's already yellow or red, might be better to go more in depth and use your system. Because you want to know actually what is happening with this person during his work. So that's where we come in with motion capture. What do? You see our two systems, the MVN Xsense Link and the Xsense Owinda. That's our hardware. I want to explain, Xsense is not a hardware company. The sensors are for us a tool. We use the tool to get data in our software, but the software is actually where everything happens. That's where we can make sure that the data we collect actually is very valid. So if we look a little bit back, small sidestep, Xsense is a research tool. We have been used in research for over 20 years. Over 1,000 universities, institutes in the world have the equipment. So there's a lot of publications, a lot of validation research. So because we have that, we can really make sure that our data is always validated, but also super reliable. So you can use it over and over, time and time again. And you don't have to discuss like, okay, was this joint angle, was that good, yes or no? Out of the question, because we have that background. However, it's also difficult for us, because we are a research tool, how do you convert this research data into something meaningful for workplace ergonomics? Because if I have the data, for example, the tennis player, I have a lot of acceleration data, angular velocities, but it doesn't say us anything when we want to create a ruler or rebound. So that's why we try to make sense of our research data, and we say, okay, we have Xsense, and then we are going to put it in another software program to make sure that we have good ergonomics analysis. So, what do we actually do? This explains it a little bit.
In many industries, manual tasks come at a hidden cost. Over 1.7 billion people suffer from musculoskeletal disorders from repetitive tasks. Work-related injuries are a major concern for organizations. There's a clear need for efficient, accurate ergonomic assessments in the workplace. Traditional methods are slow and rely on outdated approaches. The data isn't objective. Not anymore. Xsense brings cutting-edge motion capture solutions that transform ergonomic assessments. Xsense provides high-quality data, giving you a clear picture of ergonomic risks. It can be used anywhere. Real-time analysis delivers quick insights, and you save time and money in the long run. 3 Xsense Ergo solutions cater to different needs. Xsense Ergo simplifies assessments, is cloud-based, provides fast standardized reporting, and objective results with familiar ergonomic standards. Xsense Ergo Live delivers real-time reporting and daily load calculations, powered by Industrial Athlete by ScaleFit. Xsense Ergo Expert offers advanced analysis, gives you full data access, streaming, exporting, and seamless integration with third-party software. Create safer, more productive workplaces with Xsense Ergonomics Solutions.
So that's a little bit what we do. I think it's always a little bit salesy, the video, but I think it does explain nice what we do. So it already said Xsense Ergo, Ergo Live, and Ergo Expert. To show you a little bit more, what we do with Xsense Ergo, at the moment it is in the cloud. So what you do, you make a recording, send it to the cloud, and there you get your ruler, your rebar, or what we call an adjustable ergonomics, where you can put in your own thresholds, your own values, everything. We are quitting with the cloud. We don't like the cloud. A lot of companies don't like cloud working. And hence we have said, okay, we are going to put this complete process offline. So hopefully as of the start of 2025, in our newest software version, we will have this embedded in the software, so you can just record, press the button, there's your report, PDF export, Excel export, whatever you want, and you have the data. So that's basically what Xsense Ergo is. The ability for you, if you already work for 10 years in your company with Rula, with Reba, or your own standards, which you can tweak in the adjustable ergonomics, you can basically digitize your current workflow. So all the data you have collected already is not lost, it's not gone, but you just go for the more objective, faster, and the reliable analysis. Super easy. It's easy to explain within the company as well, like, hey, we're just making the next step in technology. That's one option. Then we have the second option, which is the Xsense Ergo Live. And with the Xsense Ergo Live product, we basically give you the ability to use software which we call SkillFit. SkillFit, and we will show you later in the demonstrations as well. Sorry. It will give you the ability to also do a live assessment. So you put somebody in the suit, and then live on the screen people can see, okay, how do I move? What is green? What is yellow? What is red? And it has the ability to do a complete reporting tool, which is fully customizable. However, it's also very extensive. So basically what you need to do is, let's say a company or a university wants to buy this, you really have to check, okay, how am I actually going to embed this into my company? What do I want to look at? So it's a little bit more extensive. This is just digitizing your current workflow. This is taking the next step into developing almost your own tool, where you have the flexibility to tweak a lot. And then we have Xsense Ergo Expert. This is what companies like Toyota, BMW use. They have their own software. They already have software that looks at the environment, the lighting conditions, the vibrations, the sound. And what we just do with our equipment, for example, to be very specific, in BMW they have 13, so 1-3 assessment criterias. And like I said, it takes them 8 hours to do one analysis. What we do is from the 13 we can automate 8, which are the most extensive ones. Take them 45 minutes already to do that once assessment, and then the lighting conditions and everything they put in by hand, but that's always the same. So that's not there's no need to digitize that. So basically we provide them with the digitized solution, and they embed everything themselves in the software. But you can imagine for this you need a lot of expertise, software engineers, your own software, for example. So we go from very easy to more flexible to something fully custom, but also needs a lot of implementation. So these are the 3 options you have, basically. So to give you a little bit more insight on what we do with SkillFit, like I said, it's very extensive. So if you look, this is a recording we made. You get insight on 6 body regions, so the lower back, the shoulder, the head, the elbow, the knee, and the hand. And it gives you a full body score. What is very nice about SkillFit, it embeds per body region an assessment on body postures. So it looks at how is the shoulder moving and in what positions are the shoulders placed. It looks at the load on the shoulder, and it looks at the repetitions of the shoulder. So if we, like 5 minutes back, I told you have all these different kinds of standards that all individually assess a specific region. With SkillFit, you have everything in one analysis. So it basically takes into account all the movement of the body and creates a score out of it. We can deep dive in this more in the second part if you have more questions. Then, in the second level, it actually looks based on NIOSH, based on ISO standards, based on the EN norms. It looks at, okay, how are the repetitions within all these body dimensions and all these body segments? And how is the force exposure in these different body regions, like the lumbar spine, the neck, the shoulder? Automatically scores everything. So in one Excel, you can basically see everything. And then we can even deep dive into specific body segments. I believe there are 17. So I took an example here for the lumbar disc compression. It looks at the evaluation time, and then it tells you how much seconds is somebody in the green, in the yellow, in the red. It gives a score for the risk based on the body postures. You can see the graph during the movement. And we can even say, okay, this was at 20 seconds. So I can go back into my recording. I can exactly see, okay, the person was standing like this. Yeah, it makes sense that it is red, for example. It looks at repetitions, so how many repetitions in total, how many per minute, the maximum load, and it even looks at the dosage model. And all this data is all based on international standards. So in this case, it looks at NIOSH action limits for the lumbar disc compression. And then we have multiple of these different kind of analysis options. So we're almost getting into the last part of this presentation. Existing customers and how do they use Xsense. So I wanted to start with Toyota and BMW first, because these are basically our biggest customers in this segment. Toyota, almost all plants now in the world use equipment. They have either one system or multiple systems per location. And we asked a few of their ergonomics people, what do you think about the system? Why do you use Xsense? So at Toyota they said, the motion capture technology developed by Xsense has been integrated with SJT. That is their software. This scores to improve the accuracy of every assessment within the Toyota ergonomics assessment. So for them, it's really about the accuracy to buy Xsense and embed it into their software. At BMW, they say it increased ergonomic stresses. Changes are made in the workplace to reduce the physical stress. So they actually use it at the workplace, interpret the data, and create new workplaces based on that. So they mock up in a specific area the new workplace, analyze it, see if it has improved, and then they implement it at the product line. The DWSM, that is their software, it enables BMW for way more comparability, so they're able to compare locations with each other, different departments with each other. It creates uniformity. Everybody does the analysis in the same way. So it doesn't matter if you are in the South African plant, or if you are in the Brazil plant, or you are in Germany. Everywhere in BMW, same analysis. And compatibility across the BMW Group production facilities. What they mean with that is they can use it in every department, from the paint shop, to the assembly, to the logistics, to everywhere, every department, they use the equipment. So that gives you a little bit of an idea how they work with it. Another nice example is Stryker Medical. Stryker Medical, do you know the company? Yeah. So this specific department within Stryker, they sell hospital beds. So what they do, they fill up a big room with a lot of doctors, HR people, and they show, okay, this is our standard Stryker Medical bed. Put somebody in the suit, scale fit on the screen, and they show actually how somebody is working with that bed. And then on the live screen, you can see, hey, actually when somebody's working with that bed, they have to bend over more, put more stress into the bed to get it moving. And then they say, okay, I have here our level 2 bed, a bit motorized, and they show it again, screen, live, everything, and they show, hey, it's already better for the shoulder and for the back. And then they still have another bed, the level 3, fully automated, fully authorized, and then they can show there's almost no load anymore. And they basically use it with ergonomics analysis as a sales tool. So it's a funny thing how to do it. If you have IKEA uses it in their warehouses in logistics. So people that do the order picking, that drive the trucks, drive the lorries, they can just equip them with the kit, press record, let them work for 2-3 hours, press the button, have all the outcomes. They can do it with logistics, and now they're going into the next step, like, okay, when the equipment arrives at the shop floors, how do the people at the shop floor work with it? So that's how IKEA does it. Another one, this is a big ergo consultancy firm in Belgium. So they supply almost 40,000 manufacturers with ergonomics analysis and about 120,000 employees. And they have a big issue in getting all the analysis done in the year. They have so many customers, and they only have so many ergonomics and health and safety people. So they really use the equipment to make sure that they can provide all the analysis in that year. So for them, it's also like the return of investment is a lot higher because they can do just more analysis in 1 year. Scania, I've been working with Scania in Sweden and in the Netherlands, and me and Andre are going to visit them next week in Brazil as well. What Scania does is also basically the same as Toyota and BMW. They use software, it's called IPS, and IPS is basically, they build the complete production line in there, but because they use their production line as, they produce by demand, sorry, that's what I wanted to say. So they never make a truck before it's sold. However, because they only produce when it's sold, the manufacturing line can go like this. Sometimes they have to push out 100 trucks a day, sometimes only 50 trucks a day. So depending on that, they change all the stations, they change all the programs and the work order. And the work order is super important for them because they say, if I have an assembly line which consists of 4 tasks, task 1 is yellow, task 2 is green, task 3 is red, task 4 is red. So what they are looking at is, okay, how can I find a way, a sequence, to say, okay, I start with a red task, then it's followed by the green task, then I do yellow task, and then I do the red task. And maybe of one of these 4 tasks, we also try to improve one, so we don't have 2 reds, but we only have 1 red, and 2 greens and 1 yellow. So we can change the sequence. So we know some things we cannot change, they will remain red, but by changing the sequence of how people has to do all these processes, it's less strain on the body. So that's how they specifically look with our systems at the production line. Like I said, I have many more examples. Happy to talk with them. If you have a specific case in your own industry, we can discuss it. I'm open to any questions. Feel free to ask them. So a specific customer case I want to talk about was what I did with the Dutch DMV, which is basically they assess trucks, they assess cars. And these guys, as you can see, have to work a lot in a bending posture. They work in these pits, they have to go in, out, above head work, below work. And for them it was very difficult to get a good analysis. So I was working with this guy who's an ergonomics consultant in the Netherlands, and he asked me, hey Jordi, can you please come with me and show how this is improving my analysis? So in the end, we did an interview with the guy, and he said, analyzing the work postures is a time-consuming and very labor-intensive task for him. It takes him a lot of time. Posture interpretation and determining the frequencies and durations are not always easy. So he says, okay, if we see this guy on the screen, what is the bending angle in his lower back? Does anybody know? Can you see from the video? I can't. What is the bending angle in his neck? I cannot see, but the system can. Shoulder, knee bending angles. So he says, I'm using Xsense to make it automatic, but also way more accurate and reliable, because if I am counting all these repetitions by my eye, I'm always making mistakes. That's why he uses Xsense. And additionally, this data and the software provide the opportunity for clear visual support. Because doing an analysis is one thing, but then you have to go to management. And management is always difficult, like, hey, how you want to improvise or improve this workstation, but that costs money. Why should I do that? And then you can show them based on the data, like, hey, there's a lot of risk for shoulder. We can already see from the past that people get injured at this place. So by improving this workstation, we can decrease the injury rate and maybe even improve the efficiency. So the knife, it cuts on both ends, which is always good for your return of investment. So it's not only about the data, but also how to convince the people that your analysis is actually making an impact for the company, for the institute, for the article you're writing in the university. That's how you can use it. And looks like this. So, last slide, and then we can go into some questions. Why to perform analysis with Xsense? It is affordable, and you have a quick return of your investment. You have way more objective and validated data. You boost the morale of your employees, because that's a thing we didn't talk about, but if you have a person on your workstation and you're standing next to him with your video camera and analyzing him, they don't like that. Whereas if they are in the equipment, they see, I feel like a movie star. I am part of the analysis. They see themselves moving in the screen. And because they see themselves moving, when you come back afterwards and tell them like, hey, you have to improve your lifting technique because it's not good, they understand way better the impact of why it is important to make that change. And changing behavior is the most difficult thing we have to do in ergonomics. So for the employee satisfaction, really important. And like I said, because of our research history, all the data is backed up by science, validation studies, articles. So there's no question anymore about, is this data valid or no? Or like with the video AI tools, the angles are not really great. We don't have that anymore. Return of investment data. This was done in Canada in 2023. They saw that if you do investments in general in occupational health and safety, the return of investment was 24% on top of the investment in manufacturing employees. For transportation, it was actually 114%. For construction employees, 34%. The biggest remark on this is, it only works when you do continuous process. If you do a one-time analysis or one-time assessment, people think of it for a few weeks, and then they go back into their own behavior again. So to achieve these kind of things, it's very important to do over and over analysis, multiple people, embed them in the process, and this helps with that. Thanks a lot. This was what I want to tell you. I hope it was clear. Any first questions, remarks, something you want to ask? Natalia, maybe you can take the mic.
Don't worry.
Buenos días. Pues hay varias preguntas, ¿no? La primera que yo quiero hacer es, ¿cómo hacen el manejo de los elementos de protección personal? Protection personal elements equipment.
No, actually, the funny thing is, you put the sensors on the body with straps. And we will show you in a bit as well. I have a strap here, I can show you.
You need to talk with the mic.
So it's not a problem to use protective equipment, like the helmet or anything else, because these sensors and the software, they take any data interference out of it. That's why Xsense is used so many times, because the sensor, it has a magnetometer, and that is interfered by computer, building, anything. But the software takes care of that. Like I said in the beginning, hardware, super easy. That's just for the tool. The software makes it work. And if you put, like the sensor, you put the sensor on top of the strap, place it on your arm. Oh, that's fine. This is it. It's stuck there. Now you can put on your protective clothing, anything. People can just work as they normally work. Helmet, no problem. We have a head sensor, but because the head is one rigid object, you can put it here, there, doesn't matter. So as long as the sensor is on the right segment, always works. And we can show you after in the demonstration. Yeah.
Thanks. Para complementar, nosotros hemos hecho muchas pruebas en la industria. Realizamos una prueba con antiexplosivos y digamos que en este caso pues las personas de antiexplosivos tienen que ponerse el traje.
I have that video on my laptop, I'll show you.
Ok. Entonces en ese sentido lo que hacen es el usuario se pone los sensores. Realmente es muy cómodo ubicar los sensores en las prendas sin que sientan como tal la incomodidad de los sensores y sobre el traje se ponen su indumentaria.
Y listo.
A ver. Esta es la prueba. Ok, perfecto.
So you can see he is in his complete gear, and on the top you see the software works perfectly fine, no problem.
Vamos, muy bien.
Excelente.
Muy bien. Muy bien.
Entonces digamos que en este caso, si se dan cuenta, la persona que está utilizando los sensores no va a sentir ninguna incomodidad. Hemos hecho varias pruebas, hemos preguntado a los trabajadores que han utilizado el traje cómo se han sentido y la verdad dicen que se sienten muy cómodos, independientemente que tengan que usar unos guantes, que tengan que usar la camiseta les permite mayor movilidad, por lo que es de licra. Entonces, la verdad, pues nos ha ido muy bien, como para complementar. Thank you. ¿Tienes otra pregunta? Ok.
Me parece muy interesante, digamos, las características físicas que tiene esta tecnología. Digamos, particularmente me llamó la atención el tamaño del housing de los sensores. Digamos, como que yo en el pasado he hecho proyectos donde uno desarrolla estos elementos in-house con plataformas de prototipado y a veces son demasiado grandes y son demasiado intrusivos en el proceso. Y creo que algo, entonces, me parece muy favorable ver que eso empieza como a despertarle a uno mucho la imaginación. In English, if you want it. I was telling that it's very impressive how small the sensor housings are, and they look very unobtrusive, because I've done that in-house, and sometimes they are too big and too clunky, and it's intrusive, and it deteriorates the experience. So you start to become creative about what you can do with these kind of systems.
Yeah, perfect. And that's exactly what the feedback of the people in the suit is. 1 or 2 minutes, you have to get used to it a little bit, and afterwards they don't feel it anymore. And that's what you actually want, because when I'm going there with my video camera, I'm going to make an assessment, people start moving differently. And that's what you not want. You just put this on, let them go, and we stand on the side, we don't do nothing, we don't even watch sometimes. Software records it, and they will just do their work.
Yeah,
and then they move normally, as they normally do, and you'll see them hanging on the screen, and then giving a red shoulder, and then doing like this, and then you're like, oh yeah, this is what actually happens. And that's what you want.
You prevent a lot of people acting out.
Exactly.
O sea, se evita que la gente empiece como a actuar de una manera no natural. I had another question.
Yes.
The interface on video looks fantastic, because it's very detailed. I was thinking to myself, can you record that on video for further analysis?
Yeah, definitely.
Acabo de decir que la interfaz es muy interesante y muy detallada, y me preguntaba si estas pantallas se pueden grabar en video para hacer aún más análisis.
It's easy.
Los sensores y después van a ver cómo es fácil de visualizar las informaciones y después tenerlas en video y también en relatorio, en reporte. Entonces es muy tranquilo.
Por acá, ya te paso. Por acá había una pregunta.
Buenos días. Especialmente, por lo que veo, pues aparentemente es un equipo infalible, pero quisiera saber si tiene alguna debilidad, especialmente en lo que tiene que ver con ruidos. Es decir, como usuarios, nosotros deberemos tener en cuenta algún factor para controlar ruidos por el ambiente, por la persona, por la tarea. Me refiero, por ejemplo, voy a utilizarlo en un horno de fundición en que la temperatura en la que está el operador van a ser 1000 grados. ¿Debo considerar algún control para evitar pues, interferencias en la señal o daños en el equipo? ¿Hay algún, de parte de ustedes, ya en la experiencia que tienen, han detectado en algún oficio o en algún ambiente en el que hayan manejado el equipo ruidos que afecten la calidad de la señal y que puedan generar distorsión pues, en la información que generan?
Yeah, this was in Spanish, so.
Okay.
You understand before.
Okay, yeah. In this case, this is a great system, but it's a challenge when the use in environments that is very tough environments, like, for example, in a heavy oven, the heat of the affect the sensors.
No.
Or, for example, the signal, if it's a lot of systems around.
It doesn't matter. That's a nice thing. For example, when I'm at a plant and they have like a lot of robots around, welding, metal, always works. You have the ability in the software to change channels, to look at what is the best frequency to measure on, and then it always works. And what I wanted to show here is like on the left, you see our software, and this is all the data that you get out of it. So this is the left shoulder angle, but you see peaks, you see all movement, but how many repetitions? How big are the joint angles? And that's why we work, for example, with SkillFit. So you can put your recording live in here, and you can assess like the arm elevation, the angles, the amount of times in the repetition in the red zone. It's automatically scored for you. So you can spend time on improving and interpreting results, use your knowledge, instead of filling in all kinds of assessments.
Okay, for example, what is based on your experience in tough situations or environments, what guidelines or what protocols or suggestions for the users how to use the best option to the extent? Because for the heat, for the temperature, for example, the radiation and so on.
Yeah, so what I most of the time see is people set up the person that needs to be measured. They take him into like the break room where they do lunch, anything like that, set everything up, and then put on his protective clothes over that, and then go to the actual workspace. And then, depending on your own company standards, you can say, I do a recording of 10 minutes. I don't want to do, if a cycle is only 30 seconds, you record 3 cycles, take the average of the 3 cycles. That's all up to you. So we give all the data, and what works the best in your environment, you can execute that. It's not that there's one best practice. It's always different from the different, from a car manufacturer to like heavy equipment, to radiation. I even have seen people using it in a clean room in pharmaceuticals, when they go into the clean room and then they have to move very slowly because otherwise skin particles will go into the medical painkillers and that kind of stuff. So they move very slowly, that's why they use the suit. But it's all possible. But it's very depending on where do you want to use it. And that's why we are here. If you have a question, come to us, and we are happy to think along. Okay, you have this specific situation. Okay, reach out, Xsense, help me. How do I do this recording? And we will help you, because we have seen it in so many different areas that we tell you, okay, maybe you should do this, or try this, or maybe this channel will work the best for you. Maybe you should focus on this parameter more. That's why we are here.
Por ejemplo, precisamente Movela nos va a ayudar con un caso especial en hidrocarburos, que obviamente las condiciones de estos entornos pues son bastante robustas, en donde pueden haber situaciones con exposición a gases, tal vez posibilidades de explosión por chispa, y la idea es que vamos a poner en prueba el sistema para ver cómo debe ser ese protocolo para que lo puedan utilizar, porque la idea es que puedan ver las posibilidades del sistema en diferentes entornos. Esa es una gran ventaja. Sí, quedó. ¿Sí? ¿O tienes alguna otra pregunta?
Cuando, por lo menos en el contexto de salud ocupacional, cuando se hacen evaluaciones de ambiente, un requisito desde las empresas, desde ingeniería, es básicamente la certificación de los equipos.
Okay.
Y le piden a uno normalmente también la norma sobre la que uno está haciendo la aplicación del método con el que rige el uso del equipo. Mi pregunta es si este tipo de equipos ya están normalizados, si hay alguna norma que sigan, si cuando a mí me piden una calibración o una certificación del equipo, ¿hay alguien que lo haga?
Did you need to translate or? Okay.
So the equipment has some of the standard certifications you need, like it's ISO certified, CE certification. But for example, if you're looking for ATEX certification, like with the explosives, we don't have that. But if there is a case that you say, hey, if I need to use it, do you have certifications or can we create certain certifications? Reach out to us. You always want to think along. Maybe we can set up a certification protocol and get the certification. So it's not like if we don't have it, we don't want to acquire it. It's just, yeah, we have to discuss that.
Okay. And the other question is about the normative or the ISOs that use for to the methodologies in ergonomics. What methodology has the system?
Yeah, I will put it up on the screen. I have a nice overview of it.
Bueno, mientras tanto, me hago por acá para que me vean. Mientras tanto, sí tiene certificaciones, las certificaciones a nivel de electricidad, lo que es la calibración del sistema, los sensores, toda la certificación está. En cuanto a la normativa, ya Jordi nos va a mostrar, pero hay algunas que de pronto no las tienen porque todavía no se ha desarrollado en esos entornos, como por ejemplo la antiexplosivo. Por chispa. Entonces, pero si es posible, si hay un cliente que lo requiera, se puede realizar esa certificación para que tengan la tranquilidad de que el sistema va a funcionar en ese entorno.
Yeah, and if we look specifically at SkillFit, the guy who developed it is a professor in ergonomics. And
George, can you
oh, sorry, yeah. I will stand over here.
Yeah, for the
So SkillFit is made at the University of Cologne by a professor in ergonomics. And what he did, basically with his assessment tool is, okay, he looks for every individual body region. He selected the best international norm that is, in his opinion, applicable to that body part. However, the nice thing with SkillFit is, this is his vision, but maybe here in Colombia you have different standards, can be. So we have the ability in the back end, in the reporting tool, to change it. So we can change, if you have a specific standard in Colombia, and you want to say, I don't want to use the EN 1005 norm for my repetitions above shoulder, but I want to use something else. In the back end, you can change the norms and all the shoulder angles and everything. So you tweak it to your personal use. That's what we want to do with SkillFit. It's possible already. And as of January 25, in our own, what we call adjustable ergonomic software, you can do that as well. So yes, this is a way to do it, but definitely not the best way. You can do very different things, and that's for us also difficult for ergonomics, because in the Netherlands, in Germany, in Europe, in Colombia, in Brazil, everywhere different standards. So we have to make something that is international standards, but adjustable. And that's what we try to achieve with this. So it's definitely not perfect, I won't say that, but you have the ability to change.
Okay. ¿Tienes alguna otra?
It's important to know that you're not going to change the visual. So ScaleFit, you're going to see the way it looks exactly the same way, but you can change thresholds. So this is important to have in mind.
Well, first, thank you so much for the talk. When you mentioned Stryker, that led me to all the healthcare possibilities that this device has. One of the questions I had is what's the maximum time that this device can record? I was just thinking, let's say a surgical case where we have surgeons that tend to have a lot of ergonomic issues, ergonomic troubles, but they have to be in surgery in the operating room for 3-4 hours at a time.
Yeah, it used to be like 6 hours straight, but now we changed the batteries and they will do double. So you can be on a suit and recording for 12 hours straight. So in that case, you'll probably be able to do a surgery and go over the whole process, and you have a single file to analyze further afterwards.
Yeah, it's good that you mentioned it, because I actually have a few customers, mainly also universities, that have a medical department and an industrial department for ergonomics, maybe the same as here, that they see the doctors, especially the specialistic doctors that do like open heart surgeries, neurosurgeons, that have to be at that table for 10, 12 hours straight. They all have neck complaints, shoulder complaints, back complaints, but they don't know how to analyze it because, yeah, there's not a lot allowed in an operating room. And that's why they put them in the equipment. Just put the surgical gloves and the cloth over it. Perfectly fine to use it for like 12 hours, what Andre said. So that's what they currently do in some articles. And I'm happy to send some of these references to you if you want them.
Bueno, es que mirando el tremendo sistema que es esto, uno empieza a pensar en las aplicaciones en el país. Hay muchas empresas preocupadas e interesadas en ser muy objetivos en cómo asignar las tareas a personas que ya sufren desórdenes musculoesqueléticos, ¿cierto? Que es como el retorno al trabajo de las personas después de que van y tienen sus tratamientos y frecuentemente se están incapacitando, y eso se vuelve un problema de productividad para las compañías, administrativo, bueno, para la salud, bienestar de las personas. ¿Ustedes qué indicación tienen de este sistema para ser utilizado testeando el trabajo de personas que están enfermas, por ejemplo, para definir lo que hablaba acerca de las secuencias, por ejemplo, de rotación, o por ejemplo, de ya llegar a un punto en que dicen, mire, de acuerdo con este proceso, se restringe el uso de tal lugar para esta persona con tal patología, hasta que usted no lo arregle, obviamente lo va a testear con este sistema en el momento que quiera ya asignar allá a la persona. No sé si en ese sentido también han tenido experiencias. Creo que ese sería un campo interesantísimo acá en el país en vista de tantos problemas que hay al respecto.
Okay. Well, the question is about, well, we can use the system with workers, but how can use the system with a user that has already an injury?
Yeah.
In this case, because the parameters changing for these users.
Exactly.
And what guidelines can you use to suggest to use the system on those people?
Yeah, very good question. Thank you. So what the system always does is you put the sensors on the body and you put in the body height and the foot length, and it will always be specific to that person. In the ideal world, you would have like a lot of recordings of the best way to perform a task. And then you can say, okay, this is the ideal world. Now I put a person in a system, let him perform his task, and we compare to that. It's possible. However, at the moment in the world, that database of how to perform an exercise or a task or anything in the best way does not exist. What you could do for your own company is say, okay, I have a workstations a lot, and I pick my team leader, who is a good worker, and he knows all the job tasks. You record all his movements. You say, okay, this is the perfect standard how somebody should move, and then that is your comparison. And then all the other employees, you let them do the same task, and you compare the two next to each other. The best guy versus the actual person in that suit. And then you can compare and show them like, okay, hey, it's 80 or 95% perfect, but 5% is on because you always look down instead of make sure that you stand up straight, for example. And you give specific tasks.
Digamos que en este caso lo que se puede hacer, basado en lo que dice Jordi, es que también se puede caracterizar. La ventaja de tener el sistema es que vamos a ver en el momento del taller que se pueden tomar unas medidas antropométricas adicionales para ese usuario. Quiere decir que estamos identificando cómo está el usuario en una línea basal, como una primera medición, y tal vez se lesionó, no sé, tuvo una lesión a los 6 meses. Se vuelve a evaluar, obviamente tiene una restricción, pero ya teniendo como una línea de base, es posible empezar a caracterizar a esa población, cómo se debe realizar esos movimientos específicamente para esos individuos que tienen esas lesiones. Y como lo decía Jordi, es posible hacerlo con el sistema porque se puede ir haciendo una base de datos propia de esas condiciones para esos individuos. Entonces es una gran ventaja porque el sistema te va a permitir, si se tienen datos previos de ese individuo, saber cuál es esa comparación. O en su defecto se pueden comparar entre dos individuos con características muy similares y empezar a caracterizar el perfil de esos trabajadores para esa actividad en específico. Este sistema no solo se puede utilizar en ergonomía, sino también se puede utilizar para entrenamiento o para retroalimentación, biofeedback, posterior a una lesión. O sea, también ayudar a ese proceso de recuperación a su estado óptimo para ese individuo, para esas condiciones. Entonces, es la ventaja que se tiene con el sistema porque ya tiene ese modelo biomecánico que está validado y que le va a permitir tener la tranquilidad de que no va a seguirse lesionando para esas condiciones. ¿Sí? ¿Alguna? You have a lot of questions.
No problem.
Sorry.
Thanks for your presentation. It is an amazing tool. I just wanted to know, what if you want to measure hand movements for surgeons or guitar players?
Yeah. So we have a tool. I don't know if I can quickly put it up, but maybe you want to explain about Manus, Andre.
Manus?
Yeah. For hand movement.
Okay. Yeah, so we integrate with a third-party hardware. It's a company called Manus. So they have gloves where you just put them on, and immediately you're going to have access to the whole movement of your fingers. So it's like very accurate. So they usually use it for animation. But of course, you can have all the data, not only visuals, but you have all the data, joint angles and stuff like this, so you can use it the way you want it. So I think Yard can show you some file. Otherwise, we can show you later how accurate it is. We don't have the gloves in here actually, but you can see by videos how easy it is to set up. Calibration is pretty quickly, and yeah, you can have like real-time assessment for your fingers.
Bueno, mientras que Jordi encuentra el archivo.
Do you have internet connection?
Esa es una gran ventaja que tiene, como se mostraba en la solución de Ergo Expert, o digamos que si no es enfocado a ergonomía, es posible también integrar otros dispositivos como guantes. Y la ventaja que tienen estos es que pueden entregar ángulos articulares también de los dedos.
This is a different application area we're also active in, humanoid robotics. But you can see the guys in a link suit, finger tracking from Manus, and actually he's controlling the robot with his fingers. So this is the addition. The hand is like almost a complete motion capture system because you have bone, 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 bone. So you need almost like 23 sensors only for the hand. So that's why we work together with another company from the Netherlands, Manus. They have the Meta gloves in which you can use finger data. So you can add that to the equipment. Downside in ergonomics in general is there's not a lot of actual standards that tell you like, okay, what is good hand movement? Because normally we only look at grip. We look like, what kind of grip? Is it a full pinch? Is it a pinch grip? That grip? So you can assess that with Manus, but it's also sometimes a little bit overkill because that's kind of easy to analyze. So it's a trade-off because do you want to invest in additional gloves, or is that actual data that you want to look at? So it's a trade-off, it is possible.
¿Alguna otra pregunta? Ah, es verdad, perdón.
Again, I was very impressed. I'm still very impressed with your interface design, that it's very dynamic, very rich, and it's impossible not to make yourself the question about I guess you have to hook up the system with a computer.
Yeah.
Does it take a lot of processing power?
We
both
have
graphical and...
we have a page which we call base, knowledge base. So it's base@movella.com. And you can just type in system requirements and it gives you a very nice list of what kind of laptop you need. In my case, I'm using a Dell Alienware, so it's a gaming laptop.
Yeah, that's perfect, yeah.
But that's enough. It's not that you need a supercomputer, so to say.
Oh, that's excellent. Yeah, because that's super convenient.
Yeah, so it's basically you take the kit, you take your laptop, you can go anywhere.
Oh, that's fantastic, because a lot of times you need mobility. So,
yeah.
Well, it's perfect. Great, thanks.
And even if you don't have a very good processing power in your laptop, for example, it's going to take longer, but it's going to work. I have had a lot of experiences with universities, for example, in which they didn't have like a very good computer. Students, for example. It works, takes longer, but you're gonna do fine. Of course, better to have an average to a high power computer, but if not, you're gonna do great.
Gracias. Me parece que hay una posibilidad de error en el registro de la información derivada de la ubicación de los sensores. Es decir, si yo hago una medición en una persona, puede ser que le ubique el sensor 2 o 3 centímetros, bueno, o en diferentes puntos articulares. Mi pregunta es, para efectos de validez de la información, ¿hay ya algún protocolo para, no sé si repetir los registros 1, 2, 3 o 4 veces? Es decir, ¿hay algún principio ligado a estadística para hacer confiables las mediciones cuando especialmente se hacen comparativas?
Very good question as well. It's also something we want to show you in the workshop. If you look at the sensors, every sensor has a label. So in this case, it says upper leg left. So I need to place this sensor on my upper leg. It doesn't matter if I place it here, there, doesn't matter. As long as it's on the upper leg. What does matter is if I put it here and I move my muscles, then the sensor will wobble because of the muscle. It's actually not movement. So that's why I say if you place it on the upper leg, place it here. This is the tractus, it's like a ligament. So there's the least amount of sensor movement. But if I place it here, there, doesn't matter. Second thing about that, in our new software, 2025 as well, it's a little spoiler, so we are doing something new which we call auto segment labeling. So the label doesn't matter anymore. Just get the sensor, put it on, you do calibration, 10 seconds, and it works. So it makes it even easier. So that's for the new software.
Tal vez no capte literalmente lo que él dijo y posiblemente esté haciendo una pregunta que ya respondió. Sin embargo, entiendo pues que un componente importante de este sistema es la parte postural, pero otro componente importante es la parte muscular. Entonces entiendo ustedes tienen posibilidad también de hacer medición de músculos, de fuerza muscular, sí. Entonces la pregunta en electromiografía, en esos casos, ¿sí hay posibilidad de que se desvíe la información? O no, o definitivamente ubicándolo en cualquier parte puede hacer lectura exacta de los músculos. Sí.
Let me take a response to them. Sorry, para que me vean. No, lo que estaba explicando Jordi, para complementar, es que si se ubica en este lado, como hay músculo, hay tejido, se mueve más. Entonces, dentro del protocolo que ya definió Movella, independientemente, tú puedes poner el sensor para ubicar muslo en cualquier lado, pero ellos sugieren que se ponga en la parte más plana del movimiento, del segmento para reducir el movimiento del cuerpo, Porque, por ejemplo, puede haber un usuario de talla grande que no tenga mucha masa muscular, sino tal vez más masa grasa. Entonces, si se ubica en una parte en donde se va a mover mucho, esos registros los va a tomar. ¿Qué es lo que hacen? Para atenuar como tal esos datos, recomiendan la parte más plana, donde están más ubicados los, digamos, tendones dependiendo de la inserción, se ubica en este punto para evitar los movimientos. Eso estaba enfocándose más hacia el uso de los sensores y el protocolo. Entonces, por un lado, independientemente, el modelo biomecánico ya tiene nombrado, o sea, tienen los nombres y es mucho más fácil poder ubicar los sensores. Ahorita igual lo vamos a ver en el taller, pero adicional también es un proceso de calibración de esa posición inicial, que también vamos a ver. Eso le va a permitir identificar dónde están ubicados cada uno de los sensores en ese entorno. La ubicación de los sensores se debe poner más en la parte plana de ese segmento para reducir o atenuar esos movimientos que generarían ruidos en la señal, para evitar eso. Y adicional con la calibración y el reprocesamiento que les vamos a mostrar, va a favorecer la calidad de los datos. La electromiografía es adicional. Esto no toma electromiografía, son sensores adicionales, hay diferentes marcas que son compatibles, se integran directamente, o sea, se pueden sincronizar de manera indirecta, en donde ya se debe ubicar el sensor como tal en ese músculo objetivo, que sería una ubicación muy diferente a la de la IMU en este caso, pero sí se podría hacer. Y la atenuación de la señal, que digamos obtener la señal de electromiografía y la señal de los sensores, también lo vamos a mostrar. Hay diferentes canales de radio que nos van a permitir diferenciar las señales que se están tomando de los sensores con respecto a la electromiografía. Entonces, todo eso ya está validado, ya hay protocolos que nos definen cómo ubicar los sensores para reducir todos esos ruidos de la señal que van a hacer que los datos sean imprecisos. Y eso ya el desarrollo de Exens, que lleva más de 20 años, lo ha atenuado muy bien. En el taller lo vamos a ver igual. ¿Sí? Sí, digamos que esto está nombrado. Ahora lo que entiendo es que no es necesario tener el nombre del sensor, se ubica el sensor y cuando se calibre el sistema va a reconocer ya el modelo biomecánico de cada uno de los sensores.
Yeah, perfect. And maybe good to add on that, it's like if we look at our company, what is for us the next step, the next technology? Now we have movement, so we know joint angles, but what we want to know is forces. And there is a way that from the movement data of Xsense, you can detect the ground reaction force, and with a biomechanical model, which is called inverse dynamics, you can calculate muscle force and joint loads. So there's no need anymore for example, EMG, because you already have the data in there. So what we want to do is what we create a lab in the box. So there's no force plates, no EMG necessary, it's everything with Xsense and in the software, and you can have a really accurate representations of what is happening in the body, but also pushing force, pulling force. That's for us the next step. We're not there yet. We are slowly working towards that, but in the coming years, it is something you may expect from us. So that is something that hopefully in the near future we can add. Technology is there. We are now integrating, for example, with force insoles. So you put insoles in the shoe. So we know, okay, if you're lifting something, the load is pushing on your foot, so I can calculate how much load I'm lifting or how much load I'm pushing. And we add that into the software. So you can have more information and more information and more information. And then the difficult part is how to translate that information to ergonomics. Because now we have muy data, but what to do with it? The standards are from 1990, 2000, 1995, it's very different. So that's, for us, the next challenge, so to say.
Otra cosa que es importante dentro de las integraciones es que si de pronto quieren ver simulación de ese tipo de variables basado en los datos que nos entregan los Xsense, se pueden utilizar software adicionales como el Anybody, que es para simulación musculoesquelética. Entonces, de alguna otra manera, con los datos, como ya están validados, si hay protocolos ya validados, también pueden obtener esa información que comentaba Jordi. Entonces, es una gran ventaja. Ahora sí.
Gracias. Tengo dos preguntas. La primera relacionada con el video. Somos humanos, por lo tanto todos los días tenemos un estado de ánimo diferente y hacemos las cosas de manera diferente. Actuamos de manera diferente en la actividad que estamos haciendo. La pregunta es, ¿por cuánto tiempo le hacen seguimiento a un trabajador para obtener un diagnóstico real de su puesto de trabajo? Esa es la primera. Y la segunda, quisiera saber si han hecho estudios en personas en condición de discapacidad.
We have people that today you're good, next day you're not that feeling well, and stuff like this. And then the second one.
Very good question, thank you. The clear answer is, I don't know. And I'll be totally honest with that, because you can record once and the data is reliable. So it's not about the quality of the data in the software, but it is more about the person. If I flew over yesterday from the Netherlands and I had a 3-hour additional flight time and I don't feel well and now I have to do a presentation and show everything, I probably move different than when I'm here tomorrow, for example, and do again the presentation. So yeah, you're totally right. What I see in companies like Toyota, BMW, Caterpillar, IKEA, they always do a measurement 3 or 5 times. And then from 3 or 5 times, they take the average, the weighted average. So in order to filter out some things, and the other thing they do is, for example, if you look at workstations, for every workstation, they put in a small person, a medium person, and a tall person. So they can see the height of the person influences how somebody work at a workstation. And then they say maybe tall people, they cannot work at this and this and this station because it's too low for them, because they have to bend over. Whereas if you have a car coming ahead and you have to put in some plugs, if you're 1.60 meters, you have to be like that. Whereas, for example, we could just plug it in. Yeah, so that's how you can differentiate in your analysis. But again, globally, there's not one clear answer on how you have to do it. So it's basically whatever you think is best, and base it on your own principle. Like, I would do 3 times, because from 3 times I can get a good average if somebody works on a cycle. But if the cycle is only 10 seconds, I might take 20 or 30, because it's only very small, and I have the data anyway. So you're not limited by the system how many times you can do it. It's more like how many times do you want to invest in it, and when do you think the analysis is good enough. I have all the variabilities of how somebody moves in my analysis. Yeah. So if you look at people with disabilities, if you have to calibrate the system, you always need to put on the 17 sensors for the full body. And for the calibration, you have to stand in an end pose. It means stand straight and hold that position for 10 seconds. If somebody can do that, works perfectly fine. If they have difficulty doing that, assist them, no problem. We have universities and rehab centers that do research on people with cerebral palsy, people that have legs, how do you say it? Yeah, cut off, amputated, thank you. So yeah, all possible, but that end pose is the limiting factor. So if you cannot do that, or assist it, then it's not the case for you. But if we look at ergonomics in general, most of these people do not work at the product line as well. So of course there might be some exemptions, but in general I've never seen somebody in a factory that could not be measured. So.
There is a possibility that use one of the options of the configurations of the suit, maybe just
upper
limb.
Yeah.
Mm-hmm.
Yeah, we have multiple. Mm-hmm. Yeah, you can do only lower body, you can only do upper body, you can do lower body with only sternum, full body with the outer hands. So we have different options for setting up the system. But in general, we say do full body for ergonomics analysis because, yeah, all the data matters.
Thank you. We have one question on one of the online attendees.
Yeah.
Is about the vibrations movement in ergonomics. It is possible to use the sense to get the vibration data to analyze it?
Yeah, so with the kit, you always get 17 sensors, but also we provide one additional sensor, and it's called the prop. It's this, basically it's your spare sensor. But in the software, you can set it up as an object, and I could just put it on the table, and then in the sensor, there's an accelerometer. So if you have like a base vibration, you could filter that one out, and all the additional vibrations you can take into account in the software. It's something you have to do manually, but the data is there. So it is optional, but yeah, it's something you have to create yourself. And even from the body, because the sensors are on the body, and you have access to the sensor data as well. So yeah, if the body is vibrating a lot because it's standing on this vibrating platform, you would see that in the data. So yes, it's possible.
Okay, and we have the last one, and we go to a brief
Coffee.
coffee break. Is about the how long does it take one assessment for a user that maybe is get the data to all the 8 hours, for example, but maybe this user has fatigue.
Yeah.
In this case, what recommend to about the time of assessment?
Yeah, you can do multiple things. You can say, hey, I just measure this person for the whole day. So you have him from start till end, and you can make a comparison from the end part and the beginning part. You could also say, I only measure him in the morning for an hour, during before lunch for an hour, after lunch for an hour, at the end of the day for an hour. Also, again, it's about your protocol. There's no specific standard way in ergonomics how to do it. It's how you want to do that yourself.
Okay.
It's possible. We have 12 hours, so.
Okay, thank you. En ese caso va a depender de lo que ustedes quieran trabajar. Ustedes son los expertos que saben de las metodologías, del proceso que deben realizar. Lo importante es que, conociendo el principio del sistema y la información que entrega, ustedes mismos puedan definir cuál es ese tiempo de evaluación, si es necesario evaluar toda una jornada. Por ejemplo, hay personas que nos han dicho que solamente les interesa la actividad porque se han dado cuenta que si al evaluar toda la jornada hay momentos en donde se repite la misma información porque es cíclica. Entonces, en ese caso, tal vez no les sirve realizar toda la jornada. Sobre todo que entre actividades siempre hay un receso, siempre tienen que cambiar de una estación a otra y es información que tal vez no les va a servir para nada, a no ser que su estudio esté enfocado en que si de pronto se me lesiona entre una estación y otra, puedo evaluar esa parte. O sea, las posibilidades son infinitas desde que sepamos cuáles son las ventajas y como el alcance del sistema. Entonces vamos a hacer un pequeño receso de unos 10 minutos mientras ubicamos los sensores en el modelo que nos va a ayudar para ya realizar el taller. Entonces hay café, hay agua, si quieren. Listo. Por favor, las personas que todavía no se han registrado, si nos pueden ayudar a acercarse acá donde está Daniel para que nos ayuden. Y para las personas que están online, 10 minutos y retomamos con ustedes. Muchas gracias.
This one?
Hola, creo que ya podemos ir retornando. Ya se me olvidó cómo se dice en español. Por favor, pues para que todas las personas que están online también nos puedan ver el taller. Si es posible que nos ubiquemos en esta parte, sería genial para que todos podamos ver el taller. Y empezaríamos en unos 2 minutos. Los esperamos. Gracias.
Okay.
El modelo. Venga.
Did you ask which sensor was not working?
Ah, no, ya lo cambié.
¿Ya lo cambió?
Sí, ya lo cambié.
Pero ¿cuál es el...?
Ah, este es el que no funciona.
Oh.
Ya lo cambié. I just
cambió
already
el...
changed. Yeah, because it's the upper arm right.
Ah, okay, you changed
And I
already
changed-
labels.
yeah,
But it's down in the right place.
So, look, this
Yeah, yeah.
cannot.
Oh, yeah.
2 minutitos. Solo para que ya tengamos...
Ok, perfecto. Entonces, bueno, ya regresamos. Espero que hayan podido descansar un poquito, tomarse un café. Lo mismo para las personas que están online. Ya vamos para nuestra fase final, que es el taller práctico. ¿Cómo va a estar conformado? Vamos a mostrarles cómo es el proceso de ubicación de los sensores para terminar de resolver esas inquietudes que tenían en cuanto a la validación de los datos, qué sucede si de pronto un sensor se corre, cómo se puede procesar desde el software. Vamos a ver todo ese proceso. Jordi y Andre van a hacer un pequeño challenge, porque ¿cuál es la ventaja de estos sistemas? Es para la parte de ergonomía o para cualquier tipo de actividad, es el tiempo, ¿no? O sea, el tiempo es lo más valioso para ustedes y necesitamos que si van a utilizar un sistema de estos, pues los procesos los puedan hacer muy rápido. Entonces ellos nos van a mostrar cómo es ubicar los sensores, yo les voy a ir explicando paso a paso, luego vamos a ir a hacer el proceso de calibración y posterior vamos a mostrar la visualización de algunos datos para que ustedes puedan ver. ¿Listo? En cuanto a las actividades, vamos a hacer actividades muy sencillas por el taller. Sergio es nuestro modelo, nos va a mostrar cómo también nos va a indicar si el sistema es incómodo de usar, si es muy pesado, todo lo que normalmente un usuario preguntaría. Y la idea es que interactuemos muchísimo. Si tienen alguna duda, alguna inquietud, lo mismo las personas que están online, por favor me lo hacen saber y lo vamos resolviendo. ¿Cuál es el objetivo de este taller? Es que empecemos a hacer una lluvia de ideas. ¿Cómo ustedes lo utilizarían en su quehacer, en el campo de trabajo, en una industria específica, a través de las actividades que vamos a realizar? Entonces, le voy a dar la palabra a André para que iniciemos y con eso ya. Ok, entonces mejor empezamos de una vez. Listo, entonces vamos a empezar. Por favor, Sergio, ubícate acá. Si se dan cuenta, pueden ver que el sistema está conformado por 3 tipos de camiseta, diferentes tallas, pero una gran ventaja que tiene es, por ejemplo, hay usuarios, como les decíamos, que no tienen una talla igual, o sea, que pueden ser más grandes, más altos, o de pronto son de talla baja. En este sentido, lo más importante es que la ubicación de los sensores se haga en la ubicación específica que nos indica Exens por el modelo biomecánico. Entonces, vamos a empezar con Andre y con Jordi, que van a empezar a ubicar los sensores. El primero sería esternón, Entonces en la camiseta hay un bolsillito, esos sensores tienen velcro, es muy fácil de utilizar. Ahora vamos a poner los sensores de hombro. Acá es importante porque este modelo biomecánico ya está validado. Ustedes saben que el movimiento de hombro tiene un rango mucho más amplio, o la articulación del hombro. Por esto ya vamos a ver cómo podemos obtener los sensores. Vamos a mirar lo que es la ubicación de brazo. Ustedes van viendo en el software que a medida que se van poniendo los sensores, se van encendiendo cada uno de los puntos. Vamos verificando, sigamos que hay un sensor, perdón, es que están apagados. Si hay un sensor que de pronto no se esté visualizando, simplemente verificamos que se esté encendido. Si se dan cuenta, es muy fácil de utilizar. No requieren quitarse las prendas, como por ejemplo los laboratorios de ambientes controlados en donde hay que ubicar marcadores. Acá la ventaja es que los sensores se ponen fácilmente a través de bandas de velcro. La primera vez ubicar los sensores se puede demorar máximo unos 10 minutos, pero normalmente nos estaba comentando André y Jordi que se demoran más o menos 2 minutos ubicando los sensores. Ajá. Sí, es posible hacerlo. Digamos que ahora por demostración, obviamente 2 personas lo están haciendo para poder ahorrar tiempo, pero normalmente es solamente un usuario el que ubica los sensores, puede calibrar o uno mismo se puede poner los sensores. ¿Qué es lo que hay que buscar? Es que el sensor de pelvis quede bien ubicado. Ese es el más importante. Y ya con las medidas antropométricas adicionales que se puedan poner, que las vamos a ver, pues va a permitir que los datos sean mucho más precisos y se personalice para ese usuario en particular. Miren que ya vamos a nivel de miembros inferiores y vamos viendo que van apareciendo los sensores. Verificamos, esa es la mano derecha, creo que está apagado el sensor tal vez. Don't worry. Como les comentábamos, los sensores se pueden ubicar en el segmento anatómico específico, pero no importa el lugar donde se ubiquen. ¿Qué es lo que hay que tener en cuenta? Es que se reduzca el movimiento. Entonces la parte más plana del segmento es la que nos va a permitir evitar tanto ruido de la señal, pues porque son actividades en donde no podemos detener al usuario o al trabajador en su actividad y decir, ay, espérate que se soltó un sensor, sino que lo que tenemos que buscar es que sea lo más óptimo posible. Miren, ya aparecieron los 17 sensores, que son los que me entregan el modelo biomecánico que ya está validado. Este modelo está validado con sistemas Gold estándar como el Bacon y el Qualisys, que eso nos permite ver que los rangos de error están alrededor de 0,01 a 0,03 grados. Entonces, digamos que es muy preciso, que nos va a permitir hacer una retroalimentación mucho más adecuada. Algo que sí me parece importante, Jordi, si te parece, es el sensor de pelvis, que es el único que tiene orientación. Ok, vamos a tomar las 2 medidas. Si se dan cuenta, para que el sistema funcione se requieren 2 medidas específicas, la estatura y la longitud del pie. Esas son las 2 principales que nos pide el sistema para funcionar. Pero si queremos que sea mucho más preciso, podemos tomar más medidas, solo que por la demostración y el tiempo pues no lo podemos hacer. Entonces se ubica la estatura y la longitud del pie. Seguramente muchos preguntan por qué la longitud del pie y sobre todo el derecho, porque cuando vayamos a hacer el proceso de calibración se va a calibrar el sistema, el entorno, sistema de referencia con respecto a el sistema de referencia de la Tierra y su base es el pie derecho. Entonces, para tenerlo en cuenta. Acá tenemos 2 métodos de calibración. Hay 3 aspectos importantes para que los datos sean precisos. La primera, la batería. Entonces nosotros podemos ver el nivel de batería. La segunda, la estabilidad de la señal, también podemos ver la estabilidad de la señal. Y la tercera es la calibración, que como siempre a todos los usuarios que les hemos realizado la demostración, se han dado cuenta que algunas veces sufren cuando se dan la instrucción de caminar normal. Vamos a ver cómo Sergio camina en estos momentos, ahora les explicamos. Pero hay dos métodos de evaluación. La primera es como si ustedes lo hacen solo para practicar y la segunda es, si nos devolvemos un momento, André, por favor. La posición neutral o la posición en T. La posición neutral es más para biomecánica como tal, ¿sí? Ahora sí vamos a darle siguiente. Acá, ¿quieres complementar algo?
So yeah, for the next step for the calibration, we are going to do 4 things. So if you look at the screen, we will start here. Then you have to hold the position for 4 seconds. Then you move around, so you can walk back, forth, until I say stop. And then you just stand still, relax. Yeah, that's it. So next, please. This is the most important part of our calibration, because this is where we get our 0 point. If you do this wrong, so for example, if we would calibrate like this, you see the feet are standing outward. But the system thinks it's this. So if I do it like that, but the system thinks this, the moment I put my feet right, the avatar will do this. So that's why we need to do the end pose. So please, tuck your shoes in between mine. Yes, perfecto. Align them straight. Yes, gracias. Your hand, like that, perfect. Yes, perfecto. Start. Yes, and start walking. It's normal walk. So normally the software will also give you audio cues, but the audio was not plugged in. So yeah, move again. Yeah. Yes, and stand still, please. Relax.
¿No puedes parar?
Yeah, just relax. So now the software will take into account that small data we have. Stand still, please. And we see calibration was good. Can you now walk back and forward a few times? So this is you. You can wave at yourself.
Algo que es importante es no comparemos este sistema 3D con un 2D. O sea, mucha gente dice, ay, pero es que el plano sagital, y quieren ver el plano sagital, esto es tridimensional. Entonces, una visualización sagital o frontal la podemos ver, pero los datos no los está tomando en 3D. Entonces, no nos pasemos tanto en que la flexión debe ser 90 grados, flexión de codo, sino estamos viendo los movimientos en los 3 ejes todo el tiempo.
So what I'm going to do now is just show you some of the data. Put it like here, and then so we can see him. And I make 2 windows. So this is the right shoulder, so drag and drop it. And the left shoulder.
Acá vamos a ver la primera parte del software Analyze, que es el que nos procesa los datos de los ángulos articulares y los ángulos ergonómicos que nos va a mostrar Jordi.
Yeah, so what I explained earlier as well, like now you have the motion capture, you have all the data, you can see the graphs. If you have your right arm and raise it, you'll see flexion and coming back. So instant data. But if we now make a recording, what does that mean? Is it good? Is it bad? How often? So that's why we say we are going to collaborate with SkillFit. So what I will do, or Andre, maybe you can open up SkillFit. So now we can see him live in SkillFit. Could you press Alt-Enter, Andre? So, yeah, perfect. And I will zoom out a little bit because so the nice thing now is, instead of having the graphs in our software, we use SkillFit. And if we now, Andre, could you press the D on the numpad? If we look here, it's static. We put it on dynamic because he is moving. If you now raise your arm again, we can see right arm elevation, the angles, the amount of seconds he is in the red zone, how many times he is in the red zone. We can see a spaghetti diagram. And over here, we can see the distance. Yes, you can see how many meters he has walked. So this is the start of our of our analysis. But we can see wrist movement, we can sideways wrist movement, you can see a squat, you can see what's happening in the grasp, and down here you can see the load, carga, so we can input the load. So Andre, can you, for example, press 2? So now you will see 2 kilograms of load will be added to his shoulders. So if you now raise your arm again, and put it on at 0 again, Andre? So you can see the difference in the load for the shoulder moment. If you keep your arm like this, can you press 2 again, Andre? So you see now the right arm increased because it takes into account the load of his hand. So this is how we can input load of somebody lifting kilos, doing that kind of stuff. Andre, could you press the G? What we can also do is do a grasp space analysis. So if you maybe stand in the place, yeah, like that, or maybe go there. We put the card here. So can you press the G again, Andre? Again. So now it takes his shoulder points as the central points. If you now move towards the bottle, we can see that if something is within reach or not. And we can see how it moves, and it's a nice tracker. All this data we can record, save, and add. So this is a very easy and simple way if you want to evaluate in your workspace, can somebody reach all the components to assemble something? And you can see the impact of it on the body. So what we are going to do now is make a recording for you. We put you over here. When we press start, you are going to move all these parts to there. Yeah? Andre, are you ready? Can you put 0 load? So we do, and then the moment he's grasping for it, then you press the space bar. If you press space bar, yeah, you can see it becomes 2. So imaginable, everything is 2 kilos. So put it on 0 again, and we say 2, 1, start. Yeah, and then all to the top, yes. And stop the recording. Gracias. So now we have recorded the data. We have to convert that data into a report. So I will quickly go to my laptop and then we'll try to show it to you guys. So what we're now going to do, I'm going to my folder and go to the reports. In here I will find all the reports I've created. And this is the one of today. You see 5th of November. So I will open it. And then in Excel, you will see all the data. This is everything we have just recorded. A lot of data, but we don't know how to use it. So we go to our big Excel macro, and I say, delete my last input. And once the Excel macro is empty, we're going to copy and paste all the data in here, and we can start analyzing the recording we just made. So I go back to my recording. I say copy all, and then I'm going to paste it here and say select language. Now I put it in Spanish for you guys. Now we have an analysis here. So we said, okay, the length of the person, you can put in a name or last name, doesn't have to. And we can see we made a recording of 23 seconds, and we have put in some thresholds. So we say everything is yellow when he does more than 5 repetitions per minute, and everything is red when he makes more than 10 repetitions per minute. But I can say here, we can change that into 8, for example. So now it takes into account 8. If we look at this recording, we see 6 body regions. It analyzes again for the body posture, the load, the repetitions, and this one is the sum of these 3. Same for the lumbar, for the neck and the head, for the arms, the hand, and the knee. If we do a quick score here, I can click at the score button, and it shows me, okay, I have a score between 32 and 42. There's a significant amount that I need to change based on these things, and it says, okay, there's definitely something we have to change here. If I go back to my report, let's say we're going to investigate what is happening in the shoulder because the load is not that high, but awkward postures and high for repetitions. So I go down a little bit, and I can check here for force exposition, the posture, and the repetitions of all the body regions, what is happening, based on NIOSH. This is a ISO standard. These are all the ISO standards, and for repetitions, it takes into account the EN 1005 norm. And we can see for the shoulders, which one is the shoulders columbar? So the force actually is not that bad in the shoulders, but for the forced postures, there is an issue. So I want to investigate that a little bit better. So what I'm going to do, I go down, and I go to the shoulders. And first, I can see here about the elevations, what was happening. So we see that we were 8 seconds in the green, 8 seconds in the yellow, and 7 seconds in the risk zone in red. Risk for postures is red, based on EN 1005. He made 11 repetitions, which comes down for 23 seconds, so it means almost 29.2 repetitions per minute, and the maximum flexion he made was 100 degrees. Repetitions in the red zone were 8, which translates to 21 repetitions per minute in total in the red zone. This is only for the shoulder movements, and if we go down, we can also look at the shoulder moment. It makes a distinction between static and dynamic. We put everything in dynamic mode because he was not static, and we can check again green, yellow, red. So the shoulder moment, so the load in the shoulder was actually quite good. The nice thing with the shoulder moments is we have a dosage model. So it calculates what is the dose on the shoulder, and it says time to 100%. That means is how many time can this person perform this task before the shoulder will get into a state of overload. So that means that after 3 hours and 30 minutes of performing this movement, probably he will have a higher risk for shoulder injuries, although the load itself was not that bad, 70 Newton meters, because 2 kilos is not that heavy, but based on these norms, after 3 hours and 30 minutes, not that good. However, now we say, okay, we made a 23-second recording, but I want to know what is the impact if this person is working on this station for 2 hours, and he had a short coffee break of 15 minutes. And I put my repetitions, I put it on 10 because I think 10 is good. So if we look at the shoulders, we see now still 23 seconds, and then the load was 0.2%. If I put it now on the evaluation for 2 hours with 15 minutes of break, I go back to here, I can see, okay, if he does this task for 2 hours with a 15-minute of break, he will get at a dose of 50% of that day. So what we can do with this type of analysis is I only have to record a really short amount of time, and then I can extrapolate it for a few hours and see what the impact is on the body without the need to record actually for 2 hours. It is extrapolation based on a mathematical calculation, so it just multiplies it by the amount of time. Downside of that is you miss the variance in the movement, because it could be that in that 2 hours he is starting to move very different. So you have to take into account, if you only measure for a short amount of time and you extrapolate, you can see what's happening with all the loads, but you miss the impact of somebody getting fatigued, moving different, because that was not recorded. But this is a way how you could analyze the shoulder movement based on top of the report we saw, hey, there's something wrong with the posture, and we go deep dive into the report and actually see where the problems are and how we can cope with it. Because in the end, this is just too low, so the improvement should be, this thing is raisable, for example. So he doesn't have to bend that low, and he has less load on his shoulders. So this is a small example. Maybe it's good to ask if people want to see other stuff.
Buenas tardes. Mi pregunta va más que todo relacionada a los datos. Yo he trabajado con Movela, he utilizado Extend2 y los Extend2 nos permiten obtener los datos tanto en formato de ángulos de Euler como en cuaterniones. Aquí no pude ver muy bien cómo están organizados los datos, entonces quisiera saber cuál es el tipo de datos que se trabajan con este nuevo dispositivo.
In this case, they work with Extend2.
Yeah.
And you know that just quaternions or Euler angles.
Yeah.
But Extends with the analyze has the biomechanical model.
Yes.
And he wants to know how to see the data about the biomechanical model.
Yeah, sure. So if we go back into our software, what I can do, and that's the nice thing, you always have access to your research data. So in here I put the joint angles, but let's say in your tennis application I want to see the impact of the movement when I look at the chain of movement. So I say shoulder acceleration, I put it here, upper arm acceleration, put it here, and I put my forearm acceleration, I put it here. So now, for example, if the person wants to make a throwing movement, we can see the kinematic chain of shoulder, upper arm, forearm. So if you, for example, shake your hand, can you do that? You'll see a lot of accelerations in the forearm, but not too many here and here. But if you make like a punching movement, you'll see the whole kinematic chain will move. All that data is available. So whatever you want to do with the biomechanical model, with the movement data, it is there, but you need some biomechanical knowledge or some skills to interpret that. And for most people who work in health and safety or in ergonomics, they don't care. They just want a good tool that gives them good information on how somebody is moving according to standards. And that's why we make the translation to skill fit. But it is there.
Yeah.
Yes? Yeah.
Yeah.
Euler, quaternions, everything. So if we look at the software, we have export capabilities. So I will open up quickly a file I just recorded. So this is somebody I recorded for football. Somebody is getting the ball and making a shot. If I say file, export file, I have the ability to export BVH, C3D, XL, FBX, MVNX, or a just regular video. And this is all the data that is available. So you have quaternions, you have accelerations, segment position, velocity, all the data. You can stream it in MATLAB, stream it in Python, make your own scripts, use Unity, use Unreal. That's what we basically do, because there's so many applications for this. We say, we get you all the data, the big bucket of data. Here it is. Good luck with it.
Yeah. Esa es la diferencia entre el Extend2, que es para desarrolladores, en donde estos datos del modelo biomecánico no están integrados. En cambio, desde el Analyze sí es posible ya tener los datos procesados, o sea, se ahorran toda la generación del modelo biomecánico y esa información es la que se transmite en tiempo real al ScaleFit, o a Anybody, o a MATLAB, a Python, a cualquiera de las otras interfaces que puedan utilizar. Aquí yo
So what we maybe can do is, Natalia, oh, sorry, you have a question still. No, what I wanted to show is the HD reprocessing. So maybe can you ask him, when I start the recording, to make 1 or 2 push-ups? Okay. And then we show him HD reprocessing as well. Okay. Yeah, can you ask him? Okay. Yeah, start. Yes, thank you. So this is our first push-up. I'll say push up, save. And then I will load the video, or the file we just made. Where are we? University. Always very organized. So this is the recording we made. And if we put it on trailing, we can see, for example, that his movement, it is already looking quite good. But if you're looking very closely, you see that the hands are not quite on the floor. And I will zoom in a little bit because it's quite difficult to see. You can see the hands are not on the floor. But they actually were. See? And the hands are moving a little bit, whereas they were static on the floor, so that's an error. So what we do in the software is what we call HD reprocessing. So I say HD reprocess. So what the laptop is now going to do in the software, it analyzes the whole recording. But we know what is happening frame by frame. We know what's happened in the past. We also know what's happening in the future. So it will analyze that and take into account things like skin movement, data that was not sent well to the receiver, and then it optimizes the file to get as close to reality as possible. And this is where it gets super, super accurate. So now if we look again, yes. Now you see the hands are perfectly still. Till the moment he is starting to get up and stand up.
Just to complete. En este caso, por ejemplo, que ustedes están en la industria en donde no pueden estar deteniendo a la persona para decir, no, hay que volver a hacer nuevamente la captura y se pierde tiempo, que es lo más valioso para ustedes. La ventaja que tiene el software es el reprocesamiento de los datos. Lo que va a hacer es, obteniendo toda esta información, a través de algoritmos, lo que va a hacer es mejorar la posición del sensor de pelvis desde la calibración, volver a calibrar, si hay movimientos o vibraciones que no tienen nada que ver con el cuerpo humano, sino que, digamos, el movimiento, de alguna otra manera va a atenuar como tal esa información, y lo que ustedes van a lograr son datos precisos, sin necesidad de estar volviendo a realizar toda la captura, porque sabemos que el tiempo es lo más valioso para ustedes. Entonces, en este caso, esa es una gran ventaja. Por ejemplo, los diferentes niveles que hay, verificar que realmente los movimientos del cuerpo los está haciendo de la manera real. Si se mueve de pronto el sensor de pelvis, es posible recalibrar sin necesidad de volver a calibrar, hacer el proceso que ustedes vieron. Entonces, esa es una gran ventaja. No.
Can make a test with a bad lifting and with a good lifting?
Yeah, sure. So you want to see like a bad lifting and a
to
good
see
lifting?
the lumbar?
Yeah, please do. So for example, so can you pick it up for me? Yes, and now try to put it like in a normal way. See, the impact is very different. And Andre, if you maybe can put in like load, let's say it is 2 kilo, you see that the impact is even higher. So if you try to do it again, see? It's super sensitive to the input you gave it, and also, yeah, if you try to keep it close to your body, and then lift straight and put it down. See the difference? Yeah, and also maybe, can you stand here?
Can you make the test
And then
with,
put it there.
can you make the test with rotation?
Yeah, sure. So if you stand there, don't move your feet, only pick it up. And now, put it back. Yeah? And now move your feet and stand in front. See the difference? It takes the body posture, so flexion, lateral flexion, rotation, into account for the load on the lumbar body.
Thank you.
Gracias.
Okay, in this case, for example, people ask the rotation of the trunk,
Yeah.
but in the visualization, they cannot see the rotation. It's just focused on the lumbar disc.
Exactly.
Okay.
But the data is there. So
Okay.
on the back end, the rotational data, lateral flex data is all taken into account into the model. So all data is there, but not in the visualization. SkillFit chose this visualization. I think it's really nice, but sometimes, yeah, I would like to have also some different changes, but hey, that's
Okay.
status.
En este caso, digamos que, claro, para ScaleFit, que es una de las posibilidades que tiene Exsense, que es una integración de un tercero, para ellos de pronto la visualización de la rotación del tronco dentro de las metodologías tal vez no es que no sea útil, sino que no la solicitan. Pero digamos que en la compresión del disco lumbar sí se puede mirar hacia los lados, las inclinaciones laterales y anterior-posterior en el disco lumbar. Pero la rotación de tronco, los datos que sí se obtienen durante la captura están desde el Analyze. O sea que en el otro software que vimos, ahí desde el modelo biomecánico ya están calculados. O sea que tienen esas dos opciones, dependiendo de lo que quieran evaluar. Y lo otro, Diana asked, how can reprocess the data? How is the process to reprocess the data when the sensor of the pelvis move?
Yeah, what you can do is, let's say that happened, you make a really short auto recording, and then in the software you have the option to say, okay, reprocess, but use the body dimensions of this new recording. So you don't lose the data of the old recording, but you say, okay, we just have calibrated again, and we use this calibration file on that recording. So then the data is not lost. So that is the best way to do it.
Okay, it is possible that we can show them how to...
Sure. I have to, that was a long time ago for me as well.
No, it's maybe a small capture, para que puedan ver cuando se mueve pronto el sensor de pelvis, cuál es el reprocesamiento que hay que hacer.
Sí.
La ventaja del reprocesamiento es lo que les digo, ustedes pueden, por eso la calibración es tan importante y por eso es que desde el pie derecho es que se realiza todo el proceso para saber dónde está ubicado en ese espacio ese individuo que tiene los sensores. Si hay algún sensor que se mueva, como el sensor de pelvis es el único que sí tiene orientación, es el que me va a permitir hacer toda nuevamente como la reconfiguración de los sensores. Y desde la calibración con el archivo se puede hacer, digamos que ese proceso. Esa es la ventaja de obtener datos mucho más precisos, sobre todo en actividades en donde requiere mucho movimiento.
So if you look at the screen now, I can go to the edit part, and there on top it says load calibration from file. So if I press that one, I select the new recorded file, and then it will apply that calibration to the file I want to use.
Okay, perfect.
So if you look at your protocol, what you could sometimes choose to do is like, you start at the recording, you make like a 5-second recording as your calibration file, let somebody do the task for 2-3 hours, and then make another calibration file of 2-3 seconds,
okay.
And you can always apply the other files to the software if something went wrong.
Ok, perfecto. Entonces, por ejemplo, uno dice, me equivoqué, me quedó mal la primera calibración o empezó a descalibrarse, tal vez los sensores están descargando y ya voy a terminar la captura. Al final de esa captura, pueden tomar otra calibración adicional. Y esa es la que le aplican a todas las capturas que realizaron para poder optimizar los datos que se obtuvieron y tal vez que de pronto se movió un poco por la ubicación del sensor de pelvis. Entonces hay diferentes métodos desde el software que me van a permitir optimizar los datos posterior a la captura. Y esa es una gran ventaja. No sé si tienen más preguntas, no sé si las personas que están online tienen alguna pregunta adicional.
Ahorita quería preguntar cómo es la relación del software con equipos anteriores. Por ejemplo, los extendos también son IMUs, entonces yo podría coger los datos de los extendos y ponerlos aquí y me va a dar el resultado.
Okay, he wants to know if it's possible that use the extends dot data and include into the analyze software.
No, unfortunately not. And the main reason for that, with the dot sensor, you only get the free acceleration, the magnetometer data, and the acceleration or the gyro data. And because we apply that data here on the biomechanical model, it's so different that that doesn't work. For us, again, if we look future, in the end, what we do well is the software and the engine that makes it work. So we want to make the engine more flexible so that you can also input your data or maybe Qualisys data or that kind of data. So hopefully in the future, yes. Now, not possible.
Gracias.
I always need to be with me, my computer, for do the calibration, or you have any app or something in your cell phone?
With this system at the moment, you have to be with the computer. We are working on something which we call the companion app. So basically with the app you can say start recording, stop recording, calibrate, that kind of stuff. That's for us like all the future nice things. So if you have the link system has a body pack. So with the body pack, that basically is a hard drive. So I've seen, for example, this very famous running shoe brand I am not allowed to mention, but you can imagine what I mean. They use it for developing the trail shoes for running in the forest. So what they do, turn on the body pack, record data for 8-10 hours, get back, and then put the data in the software, process it, and you have the data. So then you don't have to be near a computer at all. So if you have specific situations, we have worked together with Red Bull for skydiving. So we calibrate on the ground, they go in the plane, they go up, and then they jump out, and we have all the skydiving data, and they download it afterwards on the laptop. So these are all the applications we have. So again, we can do a lot, but sometimes things are also very specific, and then just come to Cinemet, come to Andre, come to me, and we tell you, okay, this is possible, and this is where the boundaries of our systems are, and this is not feasible anymore.
Okay, no sé si tienen alguna. Así.
Yes and no. In our software, no. 10 years ago, we had actually a biomechanical model for the horse. So if you will deep dive very deep into I have a customer in Switzerland, actually, that made a software which is called 4D Vets, and it's a gait analysis tool for dogs, based on our data. So it is possible, yes, companies do develop these things, but it's something you need to do yourself. So build your own biomechanical model and everything, but yes, you can use these sensors for it.
Okay. Dame un segundo ya. Hay dos preguntas online. The first one is, this is the first software Analyze Pro, and the other one is Skill Fit, right?
Yeah,
but it is not necessary has Skill Fit and Analyze. Through the Analyze.
Yeah. So you can say, okay, I want with Skill Fit, we only need to stream the data. Maybe that is good to show. So what we do is we stream data in SkillFit over the protocol. So actually what SkillFit only needs as software is the quaternion data and the character data. We stream that in Unity in SkillFit, and they calculate their own joint angles and everything. Because they can do that, we have a software version called MVN Analyze Plus. And Plus only allows for streaming data in different software platforms, but then also has a different price. And with MVN Analyze Pro, which is this software, you have all software access, all data access. You can do anything with it you want. So if you want to use ScaleFit with our software, you can do hardware plus ScaleFit. Or you can say, I want everything that you say, hardware, Pro, ScaleFit, or only hardware and Pro, no ScaleFit. So we have, again, very flexible.
Thank you. También, para complementar la pregunta, por ejemplo, si ustedes están familiarizados con Python, con MATLAB, desde el mismo Excel es posible procesar los datos, crear sus propios macros. También hay otros software que son terceros como Anybody, que es para simulación, como lo habíamos hablado. Hay diferentes posibilidades porque el Extend te permite exportar en diferentes tipos de archivos. Entonces, digamos que no está sesgado solamente a utilizar el software. Creo que mientras tanto. No sé si vamos a mostrar algo más. Bueno, tenemos otra pregunta y es, this is another question. For example, there is any possibility to integrate or synchronize sensors for get the environment data like noise, like temperature? It is possible to synchronize with the Xsense?
Theoretically, yes. But you would need to do that in a different platform. So I would do that in MATLAB or in Python or something. That's where you bring all the data together. But then you're talking about environmental and about temperature, heart rate variability, that kind of data. But if you want to integrate, for example, EMG data, we have a direct integration for EMG data in our software. So if you, for example, want to use Delsys, you can see the EMG graphs in our software. If you export the data, it will export it all together. So that's what we call a hard integration, and all the other ones are soft integrations, which you need another platform to get the data together. But it is possible.
Okay. Okay. Vibration. I know that it is possible with the accelerometer. And get the information to process the data to get the jerks data for vibration, right?
Yeah. So, like I said, if we just take one sensor, I can get the hand sensor and we put it on the table. You can see what is happening with the accelerations. Let me quickly go here. Where is the hand? Segment. Here it is, right hand, acceleration. So let's imagine we have the prop sensor. Can I get your right hand? Yes. I'll put it on the table. We have 0 acceleration. This is how you measure the vibrations. So we just get an additional sensor, put it at a place, make sure the static vibration. See, because if I jump here, you'll see actually measuring my jump from the table. So it's super accurate, but you need to filter out the noise, so to say. There will always be a base vibration, which you don't want to take into account. Well, you see the difference. So this is how you could do it.
Ok, digamos que en ese caso, por ejemplo, sé que para los análisis de vibraciones se enfocan de pronto en mano, en brazo, podrían tener los datos desde estos sensores directamente o en cuerpo general desde el centro de masa, porque también entrega, digamos que esos datos. Ya sería procesarlo de manera independiente con otros programas que igual, digamos que dentro del soporte nosotros podemos darles. Esa es una ventaja. Ya te voy a dar a ti la palabra y ya respondo las otras 2 preguntas que hay online.
So my question is more regarding about the lifespan of the device.
Yeah.
Is there any projection how many years of updates the device, either this software or the other one, the yellow?
Yeah. ScaleFit, yeah.
Yeah. How many updates of that each software?
It's highly dependent on what you want. We have the ability to sell you a yearly license, and then every year the updates will just be included. We also have the ability for multi-year license, so 3 years, 5 years, or even longer. And then it's basically we check, okay, if it's yearly, you get all the yearly updates again. We have an option to buy a lifetime license because universities, sometimes for tender purposes, need lifetime. And then the first 3 years, all the updates are included. After 3 years, you have the ability to get an upgrade license. So then you can upgrade to the newer software. Not necessary. So if you say, I'm perfectly fine with how the software works, keep it like this, it will work indefinitely. So the hardware, actually, the last version is from 2017. And this is one of the systems from 2017. So you can imagine that still it works perfectly fine. After already 7 years in use, there's no issue. So the lifespan is, actually the hardware is a little bit too good. But it should break more often, no kidding. But yeah, it's super robust.
Okay, so I could say I have lifetime support from Novell.
Support is always 24 hours a day, 5 days a week, because we have offices in China, we have offices in the Netherlands, we have offices in the US. So we can cover the global time span. Always, we try within a day to have all the answers in for you.
Thank you.
Bueno, y la otra pregunta era enfocada al soporte técnico, technical support. In Colombia, Cinermed realiza también todo el soporte técnico, el acompañamiento durante el proceso de capacitación, durante el proceso inicial, cuando ustedes quieren crear un proyecto de implementación de tecnología, los acompañamos durante todo el proceso y posterior a finalizar la garantía, igual ofrecemos también los servicios postventa para que siempre puedan utilizar el sistema de la mejor forma. O sea que ya sea algún problema técnico, algo enfocado a algo aplicativo, nosotros podemos también orientarles. Si tal vez no podemos resolver algo, ya pasamos al soporte técnico desde Movela para que puedan apoyarlos también durante el proceso. Esa era también una pregunta que nos hacían. I think the last one.
Sure, no problem.
There is another question. She wants to know how can get the data to process the algorithm with a NIOSH methodology into the scale fit.
Yeah, so ScaleFit does it automatically on the back end, and they only use the NIOSH action limit, so not the complete NIOSH. I've requested it a lot internally because, like I said, in 2025 we are first going from the cloud to offline software. And my next big thing I want to have embedded is a full NIOSH, like the NIOSH or multi-NIOSH as a report. So that will be, hopefully in the course of 2025, we will add, next to we already have then Rula, Reba, adjustable, NIOSH. And then I think we have a very nice portfolio already that we can use. So hopefully, unfortunately I cannot set a timeline for you guys, would love to do that, but not possible, that somewhere in 2025 we will have a NIOSH as well in the reports.
Ok, thank you. ¿Alguna otra pregunta? ¿No? Ok, bueno, hasta que sería el taller, nos rindió bastante el tiempo, hubo muchas preguntas, there is a lot of questions, but very interesting. Si tienen alguna duda, alguna inquietud, algún apoyo adicional, la Universidad del Bosque también los puede apoyar. Ellos cuentan con la tecnología del Exens. También si requieren de nuestro apoyo desde Cinermed o seguramente desde Movela van a poder contar con el apoyo. Ya hemos tenido la posibilidad en un par de ocasiones trabajar en una campaña de concientización. Ustedes vieron que la mayoría de los casos de éxito que conversaba Jordi estaban enfocados a industria que tal vez para Colombia o para Latinoamérica no es su enfoque como tal. O sea, porque tenemos otro tipo de industria enfocada a lo agroindustrial, de pronto hidrocarburos, que igual también es una empresa fuerte, laboratorios clínicos, etcétera. Lo que nosotros queremos realizar es tener casos de éxito también en Colombia. Porque claro, o sea, obviamente, como siempre lo he dicho, siempre hay un enfoque comercial. Nuestro objetivo también es poder proveer la tecnología, pero lo más importante es que ustedes ya sepan cómo aplicarla en su quehacer. Entonces, en este sentido, no es que nosotros les vendamos la tecnología, sino que ustedes mismos, a partir de sus propuestas y de sus ideas, puedan decir, necesitamos el Exens. Entonces, esa campaña de concientización la estamos haciendo con algunas empresas de la industria, el apoyo de la Universidad del Bosque para realizar una de las primeras pruebas que vamos a hacer para que podamos crear esos casos de éxito. Nuestro objetivo es que ustedes también puedan vincularse a una comunidad de captura, movimiento, pero en ergonomía, y nos puedan también proponer nuevas ideas que permitan que Movela pueda crecer a nivel de Latinoamérica. Entonces, los invitamos a que a través de nuestros contactos de Cinermed puedan tener acceso también a demostraciones con la tecnología y tener un acercamiento mucho más amplio de cómo utilizarla. Muchísimas gracias a todos. Thank you so much for your help, Andre and Jordi. Your knowledge is very important for us because we are an expert about the technology, but I'm not an expert in ergonomics. So your knowledge is very, very valuable for us. Gracias a ustedes por haber estado. Sabemos que pues estar acá tan temprano, después de un lunes festivo, no es tan sencillo, pero igual, muchísimas gracias para los que se conectaron y los que pudieron estar presentes. Gracias por todo. Un aplauso para todos.
No, agradecer de nuevo, Natalia, por la charla, las puertas quedan abiertas en la universidad, en nuestro laboratorio de ergonomía. Cualquier proyecto que nosotros vayamos trabajando también, lo importante es crear públicos, que esa es nuestra tarea fundamental como universidad, que estas tecnologías vayan bajando poco a las nuevas generaciones y vayan viendo y proyectándose en que se pueden utilizar a futuro. Entonces, pues gracias de nuevo a todo el equipo. ¿Vale?
We would like to take a picture for all of you, if you want. Gracias a los que se conectaron online. Esperamos que podamos empezar a hacer enlaces y podamos hacer una estructura mucho más fuerte en lo relacionado con esta tecnología en ergonomía. Muchas gracias, que estén muy bien, feliz día.
Si quieren, los invitamos aquí a pasar y ya viene el fotógrafo y nos toma una fotico. Yo creo que más o menos en unas 24 horas ya tendrá subtítulos el video en caso quieran repasar algo de lo que se vio y lo quieran utilizar como material de clase o para pues, recordar algo que hayan visto. ¿Listo?